Dear students, we have already discussed about the first two types of chemical reactions. Those are combination and decomposition reaction. Now we are going to discuss the third type of chemical reaction, that is displacement reaction. See here, what is meant by displacement reaction? You might have heard the word displacement. Displacement, placement, displacement means displacing means what? Changing the place. Here in a chemical reaction, in chemical reaction also, some things are going to be displaced. Means some reactants or in the products, some things are going to be displaced. How it is? Suppose I'll give you the one example. The sodium react with the calcium chloride gives sodium chloride with the calcium. So here what happens? Sodium and calcium chloride are reacting each other. Sodium is there here. Here calcium chloride is there. But the products are what? Sodium chloride and calcium. So what happened here? The sodium was alone. Calcium was with chlorine. The calcium is with the chlorine. Calcium ions are with the chlorine ions to form the calcium chloride. Calcium is with what? Chlorine. But here you see that the calcium is displaced and the sodium is with the chlorine. Means what happened? The sodium is displacing the calcium. Sodium is displacing the calcium and sitting with the chlorine to form the sodium chloride. And calcium is coming out. Sodium is sitting with this to form the sodium chloride. But calcium is coming out. Sir, then we can write NaCl2. You are not supposed to write. Sodium chloride means NaCl. We have studied in 9th standard how to write the compound. Depends on the valency of the ions here. Sodium valency is 1, chlorine valency is 1. So that they are coming. Here in the calcium, what happens there? Chlorine valency 1, calcium valency 2. Means 2 plus 2 ions here. See the CaCl2. So that we are writing here. But in the sodium, both the valency 1. So that NaCl we are writing. So no need to get confused here. I hope you have already studied in the 9th standard here. See, sodium is displacing the calcium and the sodium is combining with the chlorine. Calcium is coming out. Calcium is displaced because of the sodium. Then can we write this? Calcium react with the sodium chloride. Can we write the calcium chloride and sodium? Here see that calcium can displace the sodium to form the calcium chloride with the displacement of sodium. Is it the right reaction of right example for the displacement? No, it is wrong. This is correct. This is wrong. Why it is wrong? Why it is correct? Here also displacement is there. Calcium is displacing the sodium, forming the calcium chloride. Sodium is out. Here also sodium is displacing the calcium and combining with the chlorine to form the sodium chloride. Calcium is out. Here displacement is there. Why can't here? In every reaction you cannot see like this, because how it takes place, it depends on the reactivity series or reactivity of the elements. Reactivity of the metals. These all are metals, sodium, calcium and all. So in your textbook, in the metal and non-metal lesson, you are going to study about the reactivity series. If you know the reactivity series, you can write or you can check that whether it is a displacement reaction or not. So what is reactivity series? The elements or the metals are arranged according to their reactivity. What is meant by reactivity? That we will discuss in the next lesson. No need to waste the time now. So just you remember that the elements or the metals are arranged according to their reactivity. See, here I have written. Can you observe? Hope you have observed. Here, what is written? Just I will rub that. This I will rub that. Don't get confusion. Sodium. This is the reactivity series I have written. Means the metals are arranged according to their reactivity. High reactive metal is written at the top and low. As you go down, you are getting the low reactive metals. So that downward arrow mark is written here. Means as you go down here, the reactivity decreases. So see there, potassium is the most reactive. So sodium is also reactive, more reactive only. Compared to potassium, it is somewhat less. Then calcium, then magnesium, which is very lowest reactive metal, means here gold. So question can be asked about this, So you might have heard, studied in the previous class, sodium and potassium are stored in kerosene. Because of this, these are highly reactive metals. When they are exposed to the atmospheric oxygen or air, suddenly they can catch the fire. So that they are not supposed to keep open. They should be, these two metals should be kept in a kerosene. See here, gold is a low reactive metal, very low. So we are using this gold to make the jewels, which cannot react with any other easily. And it is these two have high what we call it as glitterness, shiny appearance, lustrous. So we are using it. See, this is the reactivity series. This reactivity series must be known to study about the displacement. We can check that whether it is a best example for displacement or it is not a displacement, like that. See, how to remember that? So what is first? First one is potassium, then sodium, then calcium, magnesium, aluminum, zinc, iron, lead, copper, Hg, mercury, then gold, then silver, then gold at last. Here one hydrogen comes, but in your textbook it is there in the metals and non-metals lesson, reactivity series is there. Here hydrogen comes. Hydrogen is written in a bracket because it is a non-metal, but remaining all are metals. These are arranged according to their reactivity. How to remember that? I'll give you one clue to remember this. How it is? See there, I'll write that. Please stop calling me as zebra in library. Call me something good. See, this is very easy to remember. You are using such words here. Please stop calling me as a zebra in library. Please stop calling me as a zebra in library. Call me something good. Call me something good. See how to remember. Please, P means potassium. Stop, S, sodium. Calling me, C, calcium. Me, calling me means magnesium, M, magnesium. As, calling me as zebra, as A, aluminium. Zebra, zinc. In, iron, Fe means iron. Library, L. Call me something good, call, copper. Again, here call means calcium, here copper, you must be known that. Call me, mercury, Hg means mercury. Something good, some, S means silver, good means gold. Very easy to remember the reactivity series. If you know this reactivity series, displacement reaction can be written easily. See that here, what it says that displacement reaction. Listen the definition of displacement reaction. It is a chemical reaction in which highly reactive element or highly reactive metal or highly reactive element can displace the low reactive element from its compound. This is called as displacement. Means highly reactive. This is the highly reactive element as compared to the low. What is that? Calcium. See that sodium, you can see that here. Calcium. Sodium is more reactive than the calcium. As you go up here, which is most, then sodium, then calcium. Sodium is most reactive than the calcium, so that it can easily displace that. Highly reactive element can displace the low reactive element from its compound. This is called as displacement. But here you see that calcium is unable to displace the sodium as it is in the top. Sodium is strong. The calcium has less reactivity, means it is a less reactive element as compared to the sodium, so it cannot. We know that when we are strong, then only we can displace others, or we can change the others place. Here the calcium is less reactive as compared to the sodium. It is not having energy to displace this. Suppose if you are going to sit in others place, means you should be able to displace him. If you are very strong, then you can displace anyone. Here see the potassium is the most reactive, it can displace this all. But here see the sodium can displace this all, but not potassium. Calcium can displace this all, but not sodium and potassium. Here see the iron can displace these all, but not these all. So one more example I will give you. Suppose here what is that? Here calcium reacts with aluminium chloride AlCl3 and forms the calcium chloride with aluminium. See that calcium is highly reactive than the aluminium. See, this is, you don't see about the ions here, what is negative ion or whatever, what we say that here chlorine is a non-metal. See that here metals, you see that calcium is most reactive, it can displace the aluminium to form the calcium chloride and aluminium is out. But if aluminium is written with the sodium chloride, can you write AlCl3 as aluminium chloride with the sodium? Is it right example for the displacement reaction? See that aluminium can displace the sodium from its compound. Aluminium is here, sodium is here. Aluminium cannot displace the sodium, but it can displace these on, but not the elements which are above it. See, aluminium cannot displace. It is the wrong example to show the displacement reaction. You are not supposed to write. So, how questions are asked in the exam means 1, 4, 5 MCQ can be asked. Which among these is the example of displacement reaction, or which among these is the wrong statement? So, you should observe that by using the reactivity series. Here see that this is right because sodium is more reactive than the calcium. Calcium is more reactive than the aluminium. This is also right, but it is wrong because aluminium is less reactive than the sodium. It cannot displace. Hope you have understood the displacement reaction. It is a type of reaction in which highly reactive element can displace the less reactive element from its compound or from its solution. Understood? So this is what we call it as displacement reaction. Next one is the fourth type of reaction is double displacement reaction. Double displacement reaction. Double displacement reaction. What is meant by double displacement reaction? See here, one example I will give you about the double displacement reaction. Here, displacement reaction, we know that. Displacement reaction, we know that. Double displacement reaction, for example, Na2SO4 reacts with the barium chloride, BaCl2. Sodium sulfate react with the barium chloride, gives sodium chloride plus barium sulfate. This is the example to show the double displacement. Here see that two compounds reacting each other to form two new compounds with the mutual exchange of their radicals or ions. Radicals can also be called as ions. See, in the displacement reactions, what we have seen, aluminium chloride here is there, means NaCl and aluminium. This is the displacement reaction. What happened here? The one element can displace the other element from the compound. One element is there, one compound is there. one element is reacting with the compound, but in double displacement, see there, two compounds are reacting each other to form two new compounds. Can you see here, new compounds we are seeing? That is what double displacement, with the mutual exchange of gas, radicals, mutual exchange of radicals or ions. See there here, this is displacement as we have studied earlier. Now you see that two compounds are combining, which are those sodium sulfate and barium chloride, and two products we are getting, sodium chloride and barium sulfate. See there, sodium is taking place of barium, barium is taking place of sodium. See there, sodium with the sulfate now, sulfate ion, barium with the chlorine ion. But in the product you see there, sodium with the chlorine and barium with the sulfate. In the place of sodium, who is there? Barium is there. In the place of chlorine, sodium is there. Means you go there, I'll come here. That policy here. Two compounds are reacting each other to form new compounds with the mutual exchange of radicals, ions. Ions are exchanging. You go there, I'll come here. So this is what we call it as double displacement reaction. What do we call it as? Double displacement reaction. Hope you have understood the four types of reactions: combination, decomposition, displacement, double displacement. In the decomposition, three types are there: thermal, photolytic, and one more electrolytic. These are the four types of chemical reactions and the examples related to. Hope you have understood about this. And many questions can be asked this topic. And next topic is about the some other reactions. Those reactions come under these only. Those are endothermic reactions, exothermic reactions, neutralization reaction, oxidation, reduction, redox, at last corrosion and rancidity. We can discuss these equations in the next class. Thank you for watching the Harideepa YouTube channel. Please watch, share and subscribe our channel. Thank you.